Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the structure. The compound is CH3, CH, CH3, CH2, CH2Cl. It contains a ketone, C is equal to O, group and a terminal chloromethyl group with a methyl branch. Moving on to the next step. Identify the longest carbon chain containing the principal characteristic group, ketone. The chain is CH3, CH, CH2, CH2Cl, which gives 5 carbons, including the carbonyl carbon. The methyl group on C3 is a substituent. Moving on to the next step. Number the chain to give the principal characteristic group, ketone, the lowest possible locant. Numbering from the CH3 end, left C1 is equal to CH3, C2 is equal to C3 is equal to CH, CH3, C4 is equal to CH2, C5 is equal to CH2Cl. The ketone is at C2 and if numbered from the other end, the ketone would be at C4. So numbering from the left gives the ketone the lower locant, C2. And for the final step, identify substituents and their positions. With the numbering C1, C5, ketone at C2, pentan, 2-1, methyl branch at C3, 3-methyl, chloro at C5, 5-chloro. Pentane, 5 carbons. Principal group, ketone at position to pentan, 2-1. Substituents, 3-methyl, 5-chloro. Alphabetical order, chloro before methyl. Full name, 5-chloro, 3-methylpentan, 2-1. Evaluate other options. A. 1-chloro, 3-methylpentan, 4-1 places the ketone at C4 giving a higher locant than necessary. B. 1-chloro, 2-oxothibutane is not a valid IUPAC name format. D. 3-2-chlorothyl, butan 2-1 would imply a 4-carbon parent chain with a 2-chlorothyl substituent, which misrepresents the structure. Therefore, the correct answer is C. Therefore, the correct answer is option C.